Hi there, welcome to the security track. This is a level 300 session. We will be learning to secure cloud workload by mitigating the security risk. My name is Tejas Sheth and I am a cloud security architect at Trend Micro. We will be walking you through the series of demos where we will be executing the exploit against the production-like workloads. Through this, we will try to share the learning on how to identify security gaps and automate incident response. We'll also discuss on mitigating the security risk at the early stage by adopting a DevSecOps practice. Let's imagine a bad day, the day when attacker exploited our AWS workload. And then we'll see that how do we respond and prevent such kind of attacks. This demo is inspired by a real event, and believe me, there is no harm made to any production systems. So in our production environment, we have three major applications. All are containerized applications. First application is a Drupal application deployed in a EC2 instance, and other two applications in same server. So first we will be doing an exploit from our home internet. We will be sending an exploit packet to a Drupal instance, and this Drupal server will execute the exploit and try to download a Python script. We will be also doing a multiple discoveries on what are the instances running on the same VPC, and after we identify, we will be doing a next level of exploit, trying to go do a lateral movement from Drupal server to the Java container. After doing the exploitation, we will try to download a next level of malicious script. This is a shell script, and it will do a shell shock attack on the neighbor container running in the same server. Now, this particular exploit will try to collect the database credential and do a CNC connection and send it outside. Right. So let's see the demo. So this is our internet facing front end application. It's a patient 0, and we have another application that's a Java based application deployed in a Kubernetes. Third application is a CSS based application running in the same instance where Java is hosted. Right. So both the applications are deployed in the EC2 instance, and we have also configured the load balancer, CDN, WAF, and similar security controls to protect the application. Now, in order to exploit it, I cannot directly exploit the application in CSS application over the internet because it has more security control added. So what I would need to do is first exploit the Drupal application. So now I have an exploit over here. There is a Ruby based exploit. So I'm just going to type Ruby, the script name, and what I want to exploit, the target website. So what it does, it identifies the vulnerability. It scans the application. It has identified that okay, it's running Drupal 8.3.1, and it is also sending a sample exploit. So it's like 1 + 1 = 2. So it means it's exploitable, right? And then immediately it sends a backdoor inside s.php. So now this s.php will answer us whenever we want to execute any command inside the server, right? So whenever we give the curl command to s.php, who am I, it will execute it for us inside the server. So now we know what's the username the Apache is running into. The next thing is the reconnaissance. Typically we use the nmap kind of a tool for reconnaissance, but here we are going to use EC2 metadata. So we are trying to identify what's the instance ID right now I am into. And after I identify instance ID, we can even go further and identify what are the permissions attached to the instance ID, right? So we can identify the IAM role, the permission, the subnet, and other details. And the next step is always identifying other servers. So here we are executing AWS CLI commands, right? And trying to identify what are the other servers running in the same region. And we have identifying that there are 2 other servers running, right? And we have also able to collect the private IP address of other servers. So now it's a time to do a lateral movement, jump from the Drupal instance to the Java application server. So what I'm trying to do here is now I'm downloading a malicious script. It's a Python script, and that Python script we are downloading from a malware box, an S3 bucket. The moment it gets downloaded to the Drupal container, we are adding it as a permission for execution, a chmod 777, and all the command that we are executing, it's happening inside the container, right? So the next thing I want to do is to call this Python script and give the target container IP address. So this is the server's private IP address, right? And we are trying to read the sensitive file cat etc shadow. So we'll try to identify sensitive information from the neighbor server's container. The next thing I want to do is download another malicious shell script on the neighbor Java container, which we have just now exploited. Now this particular container, when we are downloading the script, it will do two things. First, it will exploit it, and then it will try to send the credential, a database credential, to our CNC connection, right? So again, I'm making the script executable with chmod 777 command, and then we'll execute it, right? So the moment when we execute this script, you can see that it will send the data outside, and as an attacker, when we identify that hey, someone has prevented us or someone has detected, the first thing comes in the mind is cleaning up our trace. I want to clean up all the logs, but instead of doing that, since the IAM role is overprivileged, I'll be trying to terminate the instance, right? So by typing the ec2 terminate instance command, I can clean up those instances wherever I have done the exploitation. But since the instances are ephemeral, it's very difficult to do the forensics, identify who has done what modification, when and how. So as a security team, we want to do three things: protect as much as possible from such exploits, and whenever we cannot protect, we want to detect it. We want to do a blameless investigation and do a proper response, right? And finally, we want to mitigate such security risk from the source itself. So let's see what we can do to implement such protection. So at the network level, we can deploy Amazon Firewall. It works at the VPC level, and it has the stateful and stateless rules. It has also an open source IPS rules, and as you know that threat intelligence is a key for the protection. The Zero Day Initiative community disclosed the highest number of vulnerability every year. So by combining the ZDI rules and the Trend Micro's intelligence, you can add the threat intelligence feed to Amazon Firewall, right? With that, you can do the parameter level protection at the early stage of detection as well. At the micro segmentation of security is also important. We can also add a RASP runtime application self-protection. It's an immunity inside the application itself. Every cloud workload can also have an intrusion prevention system, anti-malware, FIM, activity monitoring, and many other similar modules. At the container level, we can also do a similar protection. We can protect the east-west and north-south traffic at the container level. And at the cloud level, you can utilize AWS Guard Duty, AWS Shield, AWS WAF, Messi, AWS Cognito for application level authentication. But still, we don't say we are secure, because security is not just a tools, but also adoption of a culture. In the previous demo, we did the attack that was having the same tools, but in the detection mode, right? So let's see that what we have detected in those tools. So these are Trend Micro Cloud One Workload Security Console. You can see here we have detected multiple events. These are the actual events that are happening on our honeypot. These are the same instances where we have done the exploit. We can see the intrusion prevention event, file integrity monitoring, log inspection, where someone was trying to modify the Docker configuration file. If we double click on the instance where we have done the initial exploit, north-south traffic, and click on the intrusion prevention events, we can identify the source and destination IP address. The source IP address is a public IP of Bangalore Network Internet, and the destination IP address is a container private IP address. We can also see the payload over there, and even that payload is visible between the container exploit. So if you remember, we have also done one of the east-west traffic exploit, right? That was from the Java container to the CSS file uploader. So here we can see the private IP address of both the containers. We can also see the data packet, the actual URL that we have used to do a CNC connection. And also there was an attack that we have identified from the first Drupal instance to the Java container instance. And not just that, we want to also send all this telemetry data to centralized data lake. After sending those data, we apply multiple machine learning models, and these particular machine learning models also do a correlation with threat intelligence. A threat intel that you can define, let's say a malicious IP address or a file hash value or a URL. The moment when we add it, it will sweep the data lake with the user defined suspicious object and the public threat intel. So after correlating the models and the threat intelligence, it generates a workbench event, the correlation when the attack happened and what attacker was trying to do. So when I click on the specific event where we have done the exploit, we can identify that the exploit came from one particular IP address, and it was trying to exploit the container with the private IP address, right? So this exploit came on north-south traffic. It was using one of the admin privilege. And if we go further, we can identify that the next exploit, the lateral movement, was trying to send the communication outside and do a CNC connection. We can check the execution profile and identify what was the process that was involved in this exploit. And we can identify here we have Apache process where multiple IPs are related, and one of the IP address where we have done the exploit that we can add it to the block list. So that particular IP address will be added to the user defined suspicious object, and also we can block it from all the endpoints. And not just that, we can also identify and correlate with the observed attack techniques, and these techniques are MITRE techniques, right? So for example, here we were trying to read the sensitive file with etc shadow. That's a sensitive file which we were trying to read from the container. We can also see some of the actual attack that was happening on the honeypot instance. So for example, here attacker from China was trying to deploy a crypto miner, and in this process we were trying to execute rmdir command, right? And we have detected those commands as well as the malicious payload. In one of our attack, we are trying to do a CNC connection, so you can see the curl command that we have executed and trying to send the credential outside from the EC2 instance. And not just that, you can also do a sweeping of certain kind of activity. For example, if I want to see how many instances were involved where attacker has executed the curl command, and we can identify there was also an attempt to identify the metadata of an instance. And not just that, we can also sweep for the specific command that was executed to terminate EC2 instance. And through that, we can identify what was the activity done, how they have done it, and we can automatically add the response. So for the response, you can take the remote shell access for the servers that was compromised if it still exists, and you can isolate those instances and do a forensics investigation by collecting those files that was a backdoor and remove those from the source. Okay, so we have exploited the application, and after that we have done the prevention, and also we have detected the exploit and the response. But now it's a time to mitigate the risk from the source itself. So at every layer of the application, there were multiple configuration vulnerability or it was application vulnerability. For example, developers are not following the best practices. Maybe let's say they are using the old libraries that are outdated, or they are storing the credentials in the application code, or maybe the DevOps guys are creating the container as a privilege access, or at the OS level there are instances that are not hardened enough, or at the cloud configuration level we were able to terminate EC2 instance just because there were overprivileged IAM roles. Now after identifying all the security gaps, what we need to do is we need to create two buckets, DevSecOps and NoOps. DevSecOps bucket, you can start adding all the list where developers can start mitigating their side of risk, and from the NoOps you can add the list where operations team has to add their side of list. For example, reducing the attack surface can be easily added to the NoOps, or mitigating the risk from the Docker image can be easily done at the DevSecOps part of it, right? So let's talk about the shift left, a DevSecOps. So we want to identify the security risk before it goes to the production. So when we are building the artifact, application artifact or a Docker image artifact, at that time we want to identify the risk, a risk like vulnerabilities, a malware or a backdoor inside the Docker image. We want to identify the secrets, whether the developers are storing any access key secret keys on the Docker image or not. We want to identify the compliance violations. For example, developer has added the SSH process in the Docker image. So this is a typical CI/CD pipeline with a security integration. So after we do a Git checkout, first thing we want to do is do a static code analysis, identify the security gaps in the code that we have written. And after we do a static code analysis, we also want to do analysis for the infrastructure as a code. Why? Because we are building the infrastructure when we are building the application artifact as well. So after the application artifact, Docker images and infrastructure is built, the next phase is testing. So in this test phase, we want to do integration test, performance test, and security test as well. So whatever the images that was built in the previous stage, that we are going to send it to Trend Micro Deep Security Smart Check. So the Jenkins is sending the image for a scanning, and here we do a malware scan, the vulnerability, the secret scan, and the compliance violation check as well. So when the smart check scans the image, it will identify the risk at every layer. So for example, here developer has used Apache 2.4 version. That was one of the vulnerable version. If it is crossing the threshold from the security standard that businesses defined, then the pipeline will fail and will not allow developer to proceed further. It will also check for the secrets. For example, here developer has used the PEM key file or AWS access key secret key, or developer has installed SSH kind of a sensitive process inside the Docker images. So the moment when the pipeline fails, developer has to go back again, remodify the Docker file and rerun the pipeline. Okay, so now let's talk about reducing the attack surface. We need to automate the security operations and enforce the least attack surface on the production environment. Okay, so here we have a production instance. Now the administrator is a GUI fan and he wants to deploy a VNC server, right? So VNC server works on the unknown port for an organization, right? And it can create a backdoor or add the attack surface. Now as a security team, we don't allow anyone to deploy additional attack surface on the production systems. So how do we prevent a user with admin privilege to deploy any unauthorized application? To prevent this, what we have done is we have deployed a Trend Micro workload security agent with the application control module enabled. So you can see here the security group is allowing the port 22 and 443 outbound internet access. When an administrator is trying to deploy a script that was installing VNC server, it has prevented even though he was an admin user. And the moment when Trend Micro module comes to know, it will trigger SNS topic. SNS topic will trigger a Lambda function where we have written the security as a code. Now this is the custom logic where you can define how you want to do a security automation. So for example, here we are removing the security group and adding a safe security group, taking out the access from the user. So again, when he tries to log in, he will not be able to do so. So the automation sends a notification to the security team on the war room. It can be the Slack or Teams. Now you must be thinking that every time a developer or any admin goes and tries to install something, I have to do some manual task, right? It means it's adding more work to me than reducing the manual effort. So let's see how we can implement the no-ops by combining these with the DevSecOps processes. Okay, so this is the same CI/CD pipeline where we have done the build and testing. After the test, we want to do a production release, right? So in the production release, we are going to scan the production server, identify security issues, and apply the intrusion prevention rules. And after applying the intrusion prevention rule, we are enabling the application whitelisting. So whatever is going to be deployed by the CI/CD pipeline, that will get whitelisted. And after the deployment, we are going to be stopping those whitelisting process. So now only the process is allowed to install the application on the production server, not the user. So we have seen the security integration in CI/CD pipeline, security for the build time and at the runtime also. Now consider a scenario where developer has a deadline for a production release. The same team has a Kubernetes access as well. Now security team can identify all the deployments on the Kubernetes are secure or not. But what if a developer decides to directly do a deployment? In such scenario, how do we identify the escape from the pipeline? We can identify this with the admission control. Admission control is a feature that will allow us to identify whether the image that is getting deployed in the production is secure or not. So at the build time, whatever scanning has been done, that is going to be pushed to the centralized management console. So here we add multiple policies, and that policy will be pushed to the sidecar container. This sidecar container will enforce entire cluster to spin up only the image that is secure and scanned in the previous stage. So if a developer tries to deploy a Docker image directly from his endpoint, he will not be allowed to do that. So now we have discussed about the compute, we have discussed about the container security, right? But what about the storage? We use the AWS S3 for storing our business critical data. How do we secure that? How do we scan the object in AWS S3? Cloud One file storage security allows us to scan the object at the rest. The moment we store this object, we can run machine learning algorithms and we can identify whether the object is malicious or not. So for example, here when a user tries to upload a file to S3 from the application form, first it goes to the S3 bucket, which will trigger an SNS topic. It will send the data to the SQS. In the backend, a scanner lambda function, which is a security scanner, it will pull the data from the SQS queue. If it's a malicious, then it will either send it to the quarantine bucket or it will add the tag to the object. And later you can do the post scan action, either remove the file from the production bucket, notify the user, and also remove the reference from the database. Now this post scan action can be customized as per the user requirement. So here we have a web application that uploads a file to S3 bucket. It has an API gateway which is connecting to the lambda function. Lambda function has a business logic that uploads a file to S3 bucket. Now the moment when the file goes to this S3 bucket, we want to secure that file. So what we have done is we have configured Cloud One file storage security and added that particular bucket for a security scan. The moment when a file is getting uploaded, it will trigger multiple lambda functions and identify whether the file is malicious or not. So these are the lambda functions that was deployed, a scanner lambda function, or also the lambda function that will do the post scan action. Now whether you want to remove the object from the source itself or you want to modify the pointers in the database. Now after we identify whether the file is malicious or not, we want to either quarantine it, so send it to the quarantine bucket, or promote it for the production use. So here, after doing this, I'm just going to push a file on the web application, and this particular file will be sent to the staging bucket first, and that staging bucket will trigger the lambda functions for the scanning, and almost in the real time it identifies the file is malicious and it will send it to the quarantine bucket. And it will also send a notification which can be human consumable, either a plain string on the SMS or an email, or it can be a JSON format which can be consumed by the application itself. Let's take a step back and think about another aspect of a security, a configuration vulnerability. AWS has around 180 plus services and keep on increasing. Every service has at least 3 configurations that can lead to the security risk. So for example, in our previous demo, we were able to terminate EC2 instance because of the overprivileged IAM role. How do we identify such risk? So first of all, we need to add the security plugins at the IDE itself. So when developer writes a CloudFormation template, they can scan those templates and immediately fix those security gaps. If developer is not able to figure out how to fix it during the writing of the CloudFormation, at least we should be able to capture that at the CI/CD pipeline. So remember the time when we were doing the static code analysis? At the same time, you can also do infrastructure as a code security analysis. You can identify the security gap that is going to be deployed in the production, right? But what about the configuration change that developers or any admin is directly doing in the console, right? How do we auto remediate such kind of task? For example, here a cloud ops guy is trying to make an RDS private snapshot a public one. So it means that it is exposing business critical data to the internet. So immediately event will be triggered by AWS Event Bridge and it will send the data to Trend Micro conformity. Conformity will send the SNS topic and SNS topic will trigger the Lambda function where we have written security as a code. Now this code is a business logic which will define whether this snapshot has to be remaining in the public or private, right? So the moment when it becomes public, automatically it will trigger this event and make this snapshot again a private. If you want to learn more about the Trend Micro tools and the automation use cases, visit www.trendmicro.com or go to the AWS marketplace and type Trend Micro Cloud One. You can subscribe for that and you can use the free trial. Don't forget to provide your feedback for the session and thanks for watching.